Today we're going to work on initial value problems. Initial value problems is a fancy way of saying that we're going to find the C value. In order to be able to find that C value, we have to be given information about the original function. Generally, they're going to give us a point. They're also going to give us the derivative. So if I have the derivative and a point, I can find the original function. So in example 1, we're giving you the derivative of 2x minus 5. We're also given that f of 2 equals 5. Well, telling us that f of 2 equals 5 is giving us the point 2, 5. And now we can go ahead and find f of x. So how do we find f of x? Well, we know if we integrate the derivative, we end up with the original function. So I'm going to integrate 2x minus 5 dx. And I put the dx on there because we're doing an integration, and we know our variable of integration is x. If I go ahead and integrate 2x, I can do that. I end up with 2x squared over 2 minus the integration of 5 is 5x plus c. And that gives us our original function f of x. But I can find that c value because I know something about the original function. I know the original function went through the point 2, 5. So if I replace my y value with 5, my x value with 2, here my 2's canceled, so I left with 2 squared minus 5 times 2 plus c. Solving for c, I have 5 equals 4 minus 10 plus c. 5 equals negative 6 plus c, so 11 is going to equal c. So my original function, f of x, is going to equal my x squared minus 5x plus 11. And there's my original function. In example 2, we're just going to get a little more complicated. We're going to throw some radicals in there. We can throw natural logs, e's. We'll see a bunch of that stuff today. So I'm going to go ahead and again integrate. As I do this, I'm going to go ahead and split this up as we have done in the past. So I get 3x over the square root of x plus 1 over the square root of x dx. Cleaning that up, I'm going to go ahead and take that radical, change it to a half power. This is to the first on top. So 1 minus the 1/2 gives us 3x to the 1/2. And to that, we're going to add x to the negative 1/2. So we're going to change that to a fractional exponent of 1/2, bringing it to the top as a negative exponent, dx. Now I can go ahead and integrate 3x to the 1/2. We end up with our original function, f of x, is going to equal 3x to the 3/2 divided by 3/2. To that, we're going to add, integrating x to the negative 1/2, we get x to the 1/2 divided by 1/2 plus c. Go ahead and clean this up just a little bit. So we have 3 divided by 3/2. I'm going to multiply by the reciprocal. So I'll end up with 2 x to the 3/2. For those of you that don't like that, if we take 3 and we're going to multiply it by 2/3, 3 over 1, we can cancel the 3's. Those become 1, so 1 times 2 gives us 2 over 1, which is 2. To that, we're going to add, multiply by the reciprocal of 1/2, which gives us 2. So we have 2x to the 1/2 plus c. Now in this problem, we're given that f of 0 equals 1. So I know that 1 is going to equal 2 times 0 plus 2 times 0 plus c. So our c value in this case is 1. So in our original function, f of x is going to equal 2x to the 3/2 plus 2x to the 1/2 plus 1. That's a mess up. Don't need that paper. In example 3, we have x plus 1 over x, all over x. And we know that f of 1 equals 4. And we're going to find our f of x. So again, we're going to integrate. I'm going to split this up. An integration of 1 plus 1 over x dx. Integrating 1, we end up with x plus 1 over x. We know, since we have a single variable in the denominator, That's going to give us the natural log of the absolute value of x plus c. Replacing our x with 1 and our y with 4. We know that 4 equals 1 plus the natural log of the absolute value of 1 plus c. Natural log of 1, conveniently enough, is going to be 0. So we have 4 equals 1 plus c. So 3 equals c. If 3 is going to equal c, we can replace that into the original function. So we end up with f of x equals x plus the natural log of x plus 3. That's a 3, not a c. There we go. In example 4, we have f prime of x equals e to the x plus 2x minus 1. Again, we're going to go ahead and integrate. Integration of e to the x plus 2x minus 1 dx. Integration of e to the x, remember, is e to the x. This goes into our original function. Plus the integration of 2x is x squared. And we increase the exponent by 1, gives us 2, divided by the new exponent of 2, so the 2's will cancel, minus x plus c. Now as I plug in 1 for my x values, I get e out. So I have e equals e to the first, which is just e, plus 1 minus 1 plus c. My 1's will cancel. So I have e equals e plus c. If I subtract e from both sides, I end up with 0 equals c. And we're going to see that when we're working with e's and natural logs, a lot of things are going to cancel out fairly nicely for us. So our final answer is going to be f of x equals e to the x plus x squared minus x plus our 0. I have one more example for you. In example 5, if I can get my papers to work here. There we go. In this one, we start with the second derivative. We give you information about the second derivative. In order to find the original function, we now have to be given something about the first derivative, which we do, and the original function. So given that, we can go ahead and integrate 2x plus 1 dx. Integration of 2x is x squared plus the integration of 1, which is x plus c. And if I integrate the second derivative, that gives me the first derivative. So I can use the information about the first derivative in order to find my c value of the first derivative. So 2 is going to equal 0 squared plus 0 plus c, or 2 is going to equal c. So my original derivative this time was x squared plus x plus 2. Now if I integrate the first derivative, I'll end up with the original function. So integrating x squared, I end up with x to the third over 3. Integration of x is x squared over 2. Integration of 2 is 2x plus c. And there's my original function. Plugging in the information I know x is 3 and y was 1. So 1 is going to equal 3 to the third over 3, which is nicely convenient, plus 3 squared over 2, plus 2 times 3 plus c. Cleaning this up a little bit, 1 is going to equal 3 to the third divided by 3 is 3 squared. So I end up with 9 plus 9 halves plus 6 plus c. Now, cleaning up a little more, 9 plus 6 gives me 15, plus 9 halves. Well, 9 halves is 4.5. So I have 15 plus 14, or 4.5 gives me 19.5, plus c. Subtracting my 19.5 over, I end up with negative 18.5 equals c. So my original function, f of x, is going to equal x to the third over 3 plus x squared over 2 plus 2x minus 18.5. Now again, I could find a common denominator, which in this case it would be 6. And on your next quiz, I will ask you for a common denominator So if my common denominator is 6, I can go ahead and multiply this through. I'll end up with 2x to the third plus 3x squared. My 2x is going to multiply by 6, so a 12x. And then I have 18.5 multiplied by 3 and multiplied by 2. Well, 18.5 multiplied by 2 gives me 37 times 3. Doing that off to the side here, we get 111. So minus 111. And there's our original function, f of x.